limit, we will get the cyber written curve of the address values. So that is again is obtained by some superpotential of the original theory, but some variables are rescaled, and the cyber written differential is given. So this is some original definition of cyber. So, but there is some other types of RBS Douglas theories can constructed in various brain was being set up. So there's another way of construction of the cyber written theory is some kind of hypersurface type similarity in the type 2D superspin. For example, we consider some theory on the two similar AD type polynomial. We will have the so-called G prime type AD, I guess that. So in the periodic lattice corresponds to the A1 to the A1G type, but it can generalize to R3, G and G prime. So we have some sort of duality, G and G prime, reshuffling the polynomial in this one. We have some sort of duality, G prime is equivalent to G prime G, and the other non-trivial duality is to B. And another classification of this RBS-Douglas theory is approach to the based on a Hitchin system with some sort of irregular similarity. So in that context, G prime is related to that. So B, some power of the similarity, exponent of similarity at some singular points. So in this context, somehow we have some common type RBS in the classification. So I explain further some properties of the AD theory, and so Cecotti and et al. Studied some BPS spectrum of the analysis of the AD theory. It's compactified on the S1. And one finds for the A1G type AD theory, they found the AD type Y system from that BPS spectrum. And this is interesting corresponding founding in AD theory is found of 2D, 4D correspondence. So we have so for the RBS-Douglas theory is somehow related to the 2D conformal field theory. So this was checked by many people. For example, the trace of the quantum modeling operator is expressed in terms of character of certain module of the 2D chiral algebra. In the Schur limit, it's expressed in the vacuum character of the 2D chiral algebra. So, and also 2D central charge is found to be related to some sort of central charge of 2D chiral algebra. So, and it's more explicit relation between 4D and central 2D theories is for general theory, RBS-Douglas theory is GBK is corresponding to 2D theory is conjecture to be this explicitly this kind of coset CFT with fractional level. This is the WG algebra with non-unitary type. So that is the analysis from that kind of ones with people. So I would like to consider this correspondence in terms of the RBS-Douglas theory defined in the omega band. So if we take the consider the cyber witness theory in the omega background, taking some epsilon parameters, one of the epsilon parameters going to 0, will have we have a somehow quantized cyber with themselves from that bit. So the spectrum of the deformed potential theory is reproduced by this kind of quantized cyber with. So this is actually differential equation, just replacing the one of the parameter of the cyber Witten curve is replaced by some differential. You see that x, maybe because this is x, z, sorry, x. So if z is taken to be I to the x, this is a sort of sine Gordon potential problem. So this differential equation has another interpretation as some insertion of the degenerate primary field or surface operator in the correlation function of the TBC. So in the case of Douglas theory, we have we can do the similar replacement that gives a quantum spectral curve for Douglas. So very naive understanding of just this replacement is due to the quantum cyber-Witten differential. The quantization is cyber-Witten differential defines some simplex structure, so it can be quantized. That gives the RPS status. That's one simple interpretation. So the ODE correspondence now applied to the RPS status. So this was this idea start from the guy Otto in some years ago. So he has shown the TBS system for the simplest RPS status model. It's called AD2 model. That can be recovered from that this differential equation. So now we want to generalize this concept to the there is an idea to the some general types of the RPS status. So we can take the right-hand limit of the linear. This is actually the ODE appearing on the tray on Tateo. With m is equal to 1. Okay. So the right-hand limit of the linear problem associated with the modified affine equation. So gives the first order linear differential equation. In some cases, we have this kind of differential equation. So we propose that this can be regarded as a quantum spectral curve for AD theory of this type by taking some special polynomial. That we are working hypothesis to connect this ODE and the RPS status. So let us check this for AR type. So so this is we have this kind of ODE, and from this ODE we can derive the T and Y systems. Actually, of this AR type obtained by Checotti and et al. And one can compute from the Y system. One can compute the effective central charge from the T-wave equations. I will show it in the next slide, but this is actually agreed with that of the calculated by Koltova-Mushra. This was also supported from the another approach, nonlinear data equations approach. So we can compute the same central charge. Another interesting property of the is the spectral duality of the ODE systems. So if we start from this differential equation, we can make it the Fourier transformation. That will give we have second order differential equation with potential R plus 1. That is a manifestation of the spectral duality of the RPS status. So we will check this the central charge actually from that of the Dore and Dan Tateo in a very different context in connection with ODE and IM. They computed the central charge from that ODE. So this is a second order with 2m. Now m2m to m2 we assume to be integers. So this is actually non-unitary minimal models with central charge distance, and perturbed by the integral model is perturbed by non-unitary model perturbed by this component. So it will make for general we can generalize it to the by some angular momentum part, and effective central charge much accurate. And this is non-unitary minimal models actually 2 and plus 2. Is the concept models with fractional level. That was actually agreed with the constructed from without in the 2D 4D correspondence. So for the higher ranked cases, we have some similar correspondence. It's not established at this moment for general G, but some numerical analysis suggests that this P corresponding to the concept model, but perturbed by some operator. So this actual central charge, agrees was predicted by the 2D 4D correspondence by Goldman Shawan. So this is the last slide, and so we have argued that the ODI correspondence between affine product field equations, G hat and G hat integral models. So interestingly, this has some sort of the Lagrange duality between ODE affine product and quantum integral. So the ODI correspondence describes the relation between ODE CFT, Alves-Douglas series, and related to super component 2D compact field series. That is non-unitary W minimum. So there are many various Alves-Douglas series. There also has some flavor symmetry. So that is expected to be related to the affine real algebra with fraction. So in that case, ODE becomes the Prinzing's analytic type equations, and the integral model is kind of Gordon model. That's another interesting question. So now we are working with the D-type and E-type vector curve and expression to the Alves-Douglas. And finally, Baxter's functional relation, including the Baxter TQ relation, can be regarded as the broad homomorphic quantization condition. That is very useful to compute the non-perturbable correction with a deformed potential strong coupling. So that this kind of integral approach is really useful to analyze the strong coupling physics further, especially the kind of arguments. Okay, thank you very much.
Are there questions?
Concerning the second point,
Yeah.
it's a 4D and 2D relations.
Yeah.
In the case of AGT, there is a people say there is a 6-dimensional theory behind. In this case,
Yeah, there's Alves-Douglas theory is there's some 6-dimensional theory behind that. Some also kind of some degeneration of the original side. It has some interpretation. I see.
Other questions? May I ask some non-expert question? So ODE, there are a lot of ODE.
Yes.
And then today I think you focus on very specific ODE.
Yeah.
I think I expect a very special of those, only those very special ODEs that will correspond to each other.
So that I want to understand. For the class of ODE associated with the affine real algebra, it is certainly corresponding to the certain integral. But other types, maybe integral, but maybe unknown integral models, I'm not sure. But only that terminology, that correspondence, that factor is, yeah.
So ultimately, so you expect that this correspondence is one-to-one?
Maybe non-integral models have, we can consider some ODE, certainly, but I'm not sure how to do it. Yeah. But kind of this affine product, we have variety of affine product, not of this type. Maybe such a affine product is some unknown